In this video, we're going to continue talking about the concepts of Chapter 2. We are now going to explore how conversion factors can be utilized in order to solve word problems. Conversion factors come from equalities. And in the previous video, we saw how equalities allow us to convert one unit to another while maintaining the same quantity. Whenever we're doing word problems and conversion, it requires that we identify certain information in the problem. We must first identify what is the given quantity units, what are the units that are needed, and then from our toolbox, meaning the equalities that we have in hand, identify the conversion factor or factors that connect the given units and the needed units. The best way to know how to do these problems is with a lot of practice. So I encourage you to go through the problems in the given worksheets in class and also the additional problems that have been suggested from the textbook. Let's do a few example problems in order to know how to solidify this concept. First, we're going to explore how to do problems that have only one conversion factor in order for us to bridge together, basically to connect together the given unit and the needed unit. The following problem states, what is the weight in pounds of an animal that weighs 1,170 grams? As we read the problem, we can identify that this specifically is our given unit. Next, this is our needed unit. So when we write this, we can say 1,170 grams is going to equal the result, and then the unit that we need is pounds. Let me just write the abbreviation of pounds, which is going to be LB. So once that we have identified the units that are given and the units that are needed, we must go into our toolbox and find a conversion factor that we're connected to. As we browse throughout table 2.7, we can observe that there is one conversion factor that actually links grams and pounds. And that is the conversion factor that states that 454 grams equals 1 pound. Now, using all of this information, how do we convert this unit to pounds? One of the techniques that we utilize in chemistry is dimensional analysis. And in dimensional analysis, we are using the idea that since equalities can be turned into fractions, then we can set up the problem such that the units that are given and how that matches our equality, it can lead us to find the result. Let me illustrate how we utilize dimensional analysis to solve the following problem. So with this, we can write down the unit given, 1,170 grams. And I'm going to multiply this by setting up my equality as a fraction. Now, what do I place in the numerator versus the denominator? What determines what number we write in the numerator versus the denominator is that specifically in the denominator, we need to write from our equality the value and unit that matches this one. So what that means is that when it comes to this, I'm going to write in the denominator 454 grams, because by writing it there, that is going to allow, through cross multiplication in a way, in essence, to cancel the units. grams will be canceled with grams because these are going to cancel diagonally. Then what do I put specifically in the numerator? Well, what 454 grams equals. That, as we can see from the equality, is 1 pound. Since in the bottom of this, there is nothing that we can cancel pounds with, that means that when we take the value of 1,170, multiply it by 1 and divide it by 454, we still have units of pounds standing in our problem. Let's perform the division. When we perform the division and we say 1,170 divided by 454, our calculator display has many, many digits. It actually has digits of 2.5709251. We are not going to utilize all those numbers. How do we determine how many significant figures or the digits that carry meaning we're going to put in our final answer? That is going to be determined specifically by the measurement given. The reason why we cannot utilize our conversion factor in order to determine the resulting sig figs is because since conversion factors are considered exact numbers, they don't contribute or slash get considered for significant figures determination for the final answer. So when we look at this problem overall, we can say, well, the measurement given has 3 significant figures. So from my calculator display, I need to round to 3 significant figures. So in this problem, my final answer is going to be 2.58 pounds. And this is how you perform at least a word problem when we utilize one conversion factor. In this case, we are deriving our equality from table 2.7. Let's do another practice problem. The following practice problem states, a doctor makes an incision 2.5 centimeters long. What is the length of the incision in meters? Now, in this problem specifically, let's first identify what is the unit given and what is the unit needed. 2.5 centimeters is what is given. Meters is the unit that is needed. So overall, we need to say 2.5 centimeters. What is the result in meters? Metric to metric equalities are not given in the exam. We can find some in table 2.4. We can find a few specifically in table 2.7, but I'm going to illustrate how when we utilize a number line method, we can derive them. And in addition, how this number line method could be utilized as a method to convert two units that are related to each other by a power base 10. So specifically from table 2.4, we can see that they actually have the equality for meters to centimeters. So we can utilize the technique of dimensional analysis in order to find the result. Using dimensional analysis, we can say 2.5 centimeters. I'm going to multiply by turning that equality into a fraction. In the bottom of the fraction, I'm going to write 100 centimeters. On the top, 1 meter. So when I take 2.5 and I divide it by 100, I find a result of 0.025 meters. My starting measurement has two significant figures. My final answer also has two significant figures. So in a way, this is one way to do it. So let me write the final result. Now, how do we utilize the number line method in order to, first of all, derive the relationships like 1 meter to 100 centimeters? Or in addition, how can we use that number line method in order to solve the problem? I'm going to illustrate first how the relationship between a basic unit and a prefix can be derived with the number line method. And then I'm going to proceed, in addition, to utilize the number line in order to find the result that we just calculated via dimensional analysis. So when it comes to the number line method, understand that in this method, I took table 2.4 and put it as a number line because essentially the separation of each of these is a power 10. When it comes to numbers, what this means is that essentially all you have to do is move the decimal place. So as I stated before, and we saw here, 1 meter equals 100 centimeters. But how can I get that information from here? Well, you don't see the unit of meters, specifically here, written from left to right. M here stands for milli, not for meters. Meters is a basic unit. And as you can see, any basic unit lives right here, right in the middle of this number line. It could be grams, it could be meters, it could be liters, it could be seconds, it could be Kelvin, it could be anything, any basic unit. So if I'm trying to say 1 meter, that specifically, I'm going to use my highlighter tool, lives right there in that dotted line. So that's where 1 meter lives. As I mentioned, what this number line allows us is to move the decimal place in direction left or right in order for us to do conversions. So what if I'm trying to relate a basic unit to the prefix centi? Since my starting point is that I start at 1 meter, I can say, well, from 1 meter to walk to centi, I will move the decimal place 1 time, 2 times, and I land at centi. So if I have a value of 1, that means that the decimal place lives right here. And if I move this decimal place 1 time, 2 times, I open 2 pockets. Since the relationship of prefixes is by a power 10, those pockets get populated by zeros, 1, 2 of them. And now that we land on centi, this numerical value is what centimeter corresponds in relationship to 1 meter. So you can see how using the number line method, we found the equivalence or the equality, I should say, between 1 meter and 100 centimeters. Utilizing the same method, what is the relationship between 1 meter and kilometers? Take a moment and derive it based on the number line method. Now, how do we use the number line method to solve the overall problem without any use of dimensional analysis? Well, we could do it in the following manner. In the number line, we can find the unit that is given. So if we go back to our problem, which says that we are given 2.5 centimeters, we first label that in our number line. We are given 2.5 centimeters. According to the problem, we need to find meters. So what that means is that if we have a written decimal place or an implied decimal place, and we are walking from centi to meters, we're walking to this point. Let me use a different color. So this is our endpoint. So we're going from the red dot to the green dot. Observe that to walk from the red dot to the green dot, meaning from centi to meters, what we must do is move our decimal place 1 time, 2 times from right to left. So if I take 2.5 and I move it 1 time, 2 times from right to left, I have 1 open pocket, which means that my numerical value now became decimal place 0, 2, 5. And if we compare that value to the result that we obtain with dimensional analysis, we can observe that the results are the same. I'm going to place the 0 before the decimal place just because I'm accustomed to that. But you can see that there are different ways that we can get to the same answer, specifically for metric to metric conversions via the number line method, which is right here, versus using dimensional analysis. Please utilize the method that makes more sense to you.